In this lesson, we're going to be covering volume of prisms and cylinders. Now, again, this is a concept that you've seen in the past. You've learned it, but I'm hoping to give you a little bit more insight in why the volume of certain things are what they are and how to approach other types of volumes in a way that would make it more understandable and easier to accomplish. So again, take notes on these just like you would in class. Our goal today is to be able to determine a volume of any prism or any cylinder. With that said, I've got a couple different prisms. I got a prism here, a square prism, and a cylinder. Now keep in mind, when we name a prism, we name it based on the base shape. Now base doesn't necessarily mean the bottom. Base means if you have two things that are congruent and parallel, those are the bases. So in this case, you can see that the bottom shape is a square and the top shape is a square. They are congruent to each other and they are parallel to each other. Therefore, they can be bases. But you could also say that this face over here on the left-hand side is a rectangle that is parallel and congruent to the rectangle on the right-hand side. So you could consider those bases as well. So when you have a rectangular prism, any face could be considered the base. If you look over here on the cylinder, you can see that there's only one set of parallel and congruent faces, and those are the circles. Therefore, the base is a circle, and that's why it's a cylinder, because the base shape is a circle. Now, based on what we see here, you guys should be able to figure out the base shapes, which we kind of already talked about. And then you can find the area of the base shapes, which we talked about how to find area of base shapes in the first lesson of this unit. And then based on what you know about volume, you should be able to figure out the volume. So go ahead and give these a shot, see what you come up with, and then push play when you're ready to review your answers. All right, like I said before, the shape of the base here is a square, right? And you could call the side face base if you want, but we're going to go with the square. So the base shape is a square, and then obviously in the cylinder the base shape is a circle. In number 2 it says, what is the area of the base shape? Well, the area of the base shape would be length times width, or in this case, you could say base times height, so it would be 3 times 3, which is 9 inches squared. And then remember the area of a circle. The area of a circle is pi r squared, so it would be pi times the radius. Well, what's the radius? This 3 represents the diameter. So the radius is going to be 1.5. So pi times 1.5 squared, or 2.25 pi, and then that would be inches squared as well. Now in number 3, it says, what is the volume of the solid? Volume, if you remember the definition of volume, volume is the amount of three-dimensional space inside an object. Area was the amount of two-dimensional space. Volume is the amount of three-dimensional space. So basically, if you were to fill these up, if they were containers and filling them up full of water, it's how much water fits inside of that object. So how would I find the volume of this first prism? Well, you guys know it. You're used to the formula. It's length times width times height, so you just multiply all the lengths. I get that. But I want to approach it a different way, and so I'm going to show you a different method in the next frame here. But before we do that, we would basically say length, which is 3, times the width, which is 3. Oh, notice that's 9. And then we'd multiply it by the 5. So 9 times 5 is 45 inches cubed. For the cylinder, we're going to take, again, we're going to take the area of that bottom shape and we're going to multiply it by 5. We'll get into more of y later, but we get 2.25 pi times 5, which is 11.25 pi. And notice the units on volume are inches cubed, cubic inches, because how many little cubes can we fit inside of each of these things? A couple things to note here. I think this is kind of interesting. Notice how the length here is 3 and the diameter of this cylinder is 3. If everything is accurate to measurement, we should be able to take this cylinder and fit it inside of this square prism, because the length here is the same as the length here, And this cylinder is going to end up being smaller because it has curvature to it. It has the same height, it should slide right in there. And so, if we were to multiply the 11.25 pi out, 11.25 times 3.14, we should get a number that's smaller than 45 because this region fully fits inside of this region. All right, with that said, let's go ahead and go on. Prisms and cylinders. Let's first understand the definition of a prism and a cylinder. A prism or a cylinder is a three-dimensional solid object which has two congruent and parallel bases. We kind of said that in the last slide. It has two congruent and parallel bases. And I like explaining it like this. It's like stacking pancakes. You know, the kind of pancakes you get at like IHOP or Denny's or just at a restaurant in general. Not the kind of pancakes that you get at home. Even though we know the pancakes we get at home are probably better, we're talking about pancakes that are made by like a little machine, a little tool, where you push a button and the same exact amount of batter comes out and goes on the griddle. And so therefore every pancake that's made in that restaurant is exactly the same size. Because we know when we're at home and your mom's making you pancakes or your grandma's making you pancakes, they throw the batter on the pan and they make, some funky shaped circle, and then they give that to you, and then at the end of it all, they have just a little bit left over, and so they put that on the pan, and that circle just ends up being smaller than all the other circles, right? You know what I'm talking about. But when we're talking about a prism or a cylinder, we are essentially saying those pancakes are all exactly the same size, and here's what it looks like. So here, we have a pentagon. In fact, this is going to be the base of a prism. Now watch this. Here is a pentagonal prism that is 1 unit high. Can you see it? The base is a pentagon. Well, wait a minute, that's the top. Yes, but imagine there is a bottom to this, and that bottom is, guess what? Congruent and parallel to the top. So we have a base of a pentagon. So it's a pentagonal prism. Now, if I take another pentagonal prism and stack it on top of it, and stack another one, and stack another one, and stack another one, you can start seeing a bigger prism. You see, we're stacking pancakes here. We're stacking the same shape up, right? We are not changing the size of it. We're not changing the look of it. It's exactly the same. In other words, we have congruent pentagons being stacked on top of each other. And so we can see it here too. We can see that's a pentagonal prism because the base is a pentagon. What about this guy? Well, this guy is a triangular prism. Now you go, well, wait a minute. I don't see it yet. Hold on, wait for it. There it is. We should see it now. But what do we see? Remember, we use the word base. What's a base? Well, you think base is bottom. No. Base isn't bottom. Base, it means congruent and parallel. So here we can see that we have a triangle in the front here and another triangle behind it. It's harder to see, but it's behind there. Those two triangles are congruent, which means they're the exact same shape and size, and they are parallel to each other, which means they're never going to intersect. So the triangle is the base shape here. Now if I stack another one next to it, and another one next to it, and another one next to it, you can see a triangular prism. The base is a triangle, and it's actually stacked up this way. Instead of going up and down, it's stacked side to side. Now, if you were to take this object and rotate it, let's see if I can do that here. If I take this object, let's see, I don't know if I'm going to be able to do this. Let's give it a try. Give it a second. Okay. If I take it and I rotate it, right, you can see that rotation there. Now I can see that the bottom might be a triangle. Okay? So it doesn't matter that the bases are actually on the bottom and top. What matters is that they are the same and they're parallel to each other. So let's go ahead and take a look at another example of this. This is a triangular prism here. Let's take another look at this. Well, we got this weird looking whatever shape. Oh, it kind of looks like a circle. This is a cylinder. Now notice how I stack these cylinders completely to the side. What is the base shape? The base is a circle. We see this side, this face, and then this one over here are going to be congruent and parallel to each other. So this is the base. What do we call it? We call it a circular prism. Well, technically no, but it has the same kind of attributes, the same way of approaching these problems. We call this a cylinder, right? But how to find the volume is exactly the same in all three of these solids. Let's go ahead and take a look at what volume is. Go ahead and write this down. The volume is the amount of space in a three-dimensional solid. We said that before, okay? In other words, it's the amount of paint it takes to fill an object. So like if you're going to the hardware store and you need to buy a gallon of paint, the volume is 1 gallon. That's how much paint is inside the can. Now, if I go to take that paint and paint a wall with it, that paint is now transferring to the wall. The surface area, we would say, is the amount of paint on a wall, or the space that the paint can fill up on a wall. But the volume is the amount of space inside an object. So in other words, if you were to think about it this way, the surface area is like your wall space, where the volume is how much air is inside your room. Okay? So how much paint will fit inside of an object or a bucket or something like that. Now there's a formula here. There's a formula that's actually beneficial to us. The volume of a prism is the area of the base shape times the height of the prism, or the height of the cylinder. So we simplify this by just saying B times H. That looks very familiar to the area of a rectangle. You see, it's the same concept. If I know the base of an object and I multiply it by its height, I can either find the area or the volume. So B represents not a number per se, but it represents the base shape, specifically the area of the base shape, and the height is the height of that solid. Let's go ahead and take a look at what I'm talking about here. Now this one is a little confusing. That's why I chose to use it as my example so we can walk through this. A lot of times we think of this, we look at this picture and we go, what the heck is that? Well, depending on how you look at it, if you look at this bottom shape, what is this shape on the bottom? Well, that would be a rectangle. It's almost like a pyramid. It's not quite a pyramid, but you can see the bottom shape is a rectangle, and we're building something on top of that rectangle. The problem is, if we're thinking about stacking pancakes, I'm not stacking an object on top of that, on top of that, on top of that, and those objects are remaining the same size. You can see, as I stack a rectangle on top of this bottom one, I get a little smaller one, I get a little smaller, I get a little smaller, because you can see the top rectangle is smaller than the bottom rectangle. You could say that the top is parallel to the bottom. That's true. But the top is not parallel, or sorry, not congruent to the bottom. And that's important. Remember, the base has to be two objects that are parallel and congruent. So in this picture, what kind of shape is parallel and congruent to any other shape in the picture? Well, we can see that this front shape is a trapezoid, and the shape behind it is also a trapezoid. And that trapezoid, those two trapezoids are parallel and congruent. So in this case, the base shape is a trapezoid. So what we need to do is find the area of the base. In other words, we need to find the area of the trapezoid. Now, you may not know the area of a trapezoid. I'm just going to give you the formula here. I'm not expecting you to necessarily have that memorized by the time this is all said and done, but if you are trying to extend your world in mathematics, it's a formula that you're going to want to know for the future. The area of a trapezoid is 1/2 B1 plus B2 times H. Now notice the difference between these bases. This says B, capital B. That means it's the shape, the base shape. So the shape is a trapezoid. These are lowercase b's. Those are lengths. So what is the base of this trapezoid? Well, the base of this trapezoid are two things that are parallel. So the two bases are 14 and 8. And then the height of this trapezoid is 6. So we can find the area of the trapezoid by plugging those values in. It'd be 1/2 of 8 plus 14 times 6. And then simplifying that, we're going to add the 8 and the 14 first. And then we'll multiply everything, and we end up with 66 feet squared. Now that is the area of the trapezoid. Now here's where I can get some students get them confused. Remember, the volume is the base times the height. A lot of students are going to say that the height of the prism is 6. It's not. You see, what was 6? The height of the trapezoid is 6. But what is the height of this prism? Well, this prism is actually laying down. It's not standing up, it's laying down. It's like you're on your feet. How do you measure your height? You measure the distance from your feet to your head. That is how you measure your height. If you're laying down, your height doesn't change. Your height is still the distance from your feet to your head. But the person that's measuring your height would be now measuring a horizontal distance if you're laying down. So in this case, the trapezoid is laying down. What is the height of the trapezoid? The height of the trapezoid is the distance from the base, the foot, to the head, the top. So the height here is 10. The height of the trapezoid is 10. So the volume of this guy is just going to be base times height. So since the base of the prism is 66 and the height is 10, our volume is just going to be 66 times 10, which is 660. And then the units on that would be feet cubed. Remember, the little one dash mark means feet. Now, this was a tough one because of the base shape and the way it's oriented. I picked a harder problem as an example to start off. The next one shouldn't be so bad, okay? So let's go ahead and, one thing I wanted to note was, and I said it earlier, that notice that the volume of a prism is base times height. The area of a rectangle is base times height. So it's the same formula, just be careful. When we're talking about the base and the height of a rectangle, we're talking about two line segments. When we're talking about the base and the height of a prism, the base is a shape of some sort. The base is like the trapezoid here, and the height is the distance from one trapezoid to the other trapezoid. So let's go ahead and take a look at a couple more problems here. Number one, we're looking for the volume of the solid. Well, it's a cylinder. What is the base shape? The base shape is a circle. Notice, this is a cylinder that's standing up. It's not laying down. So what's the bottom shape? The bottom shape is a circle. So let's find the area of the circle. The area of the circle is pi r squared. Now normally we use the letter A for area, and that's true, you could, but I'm using capital B to represent the area of the base shape, the circle. So notice it says that the diameter is 18. That would imply that the radius is 9. So the area of the base shape is pi times 9 squared, which is 81 pi. From here, we would just take the base shape and multiply it by the height. And the height in this case is going to be 8. So it's 81 times 8, or 81 pi times 8, which is 648 pi centimeters cubed. For number 2, oh boy, that one looks ugly. That's a hexagonal prism. The base shape is a hexagon. Again, it's standing up, so that's kind of nice. But how do we find the volume of a hexagonal prism? Well, it's exactly the same way as any other prism. You multiply the area of the base times the height. But then the question becomes, how do I find the area of that hexagon? Well, fortunately in this particular problem, it gave us the area of the hexagon. It says that the area of the hexagonal base is 462. So we don't have to calculate it like we did here when we found the area of the circle or when we found the area of the trapezoid. We just need to plug it in. The volume is equal to the area of the base times the height. And since the base shape has an area of 462, we plug that in. And the height here is 21. So we'll just multiply all that out and we get 9,702 feet cubed. All right, last problem. What is the volume of the triangular prism below? Now this guy, if you were to classify this, what is the base shape? Well, the base shape, some students might say, it's a rectangle. I can see the rectangle underneath. Remember, base doesn't mean bottom. Base means congruent and parallel. What are the two things that are congruent and parallel? Well, in fact, we have a triangle on the front and a triangle on the back. So the base shape is a triangle. And guess what? It said so right here. The base shape is always named in the prism. It's a triangular prism, so the base is a triangle. Now we have to ask ourselves, is this triangular prism standing up or laying down? It's laying down because the triangles are not on the bottom. So we need to consider that when we're figuring out this volume. The first thing we need to do is figure out the area of the base shape, or the area of the triangle. Notice the lengths of the triangle are 9, 12, and 15. 9, 12, and 15. The 8 is not part of the triangle. How do we find the area of a triangle? Well, the area of the triangle is 1/2 base times height. The base of the triangle, that is. Now, why did I put 9 and 12 here? Remember, the base and the height of the triangle always have to be perpendicular to each other. They always have to form that right angle. The 9 and the 12 are the base and the height. The 15 is just the hypotenuse. So simplifying this, we end up with 54. That's our area. And now we have to multiply that by the height of the prism. So 54 is the base shape. And then what's the height of the prism? Well, the height of the prism is the distance from one triangle to the other triangle. Because this is laying down, the height of this guy is this length, right? Just like you would if you were laying down. To measure your height, you would measure horizontally. You'd measure from your feet to your head when you're laying down. So we get 54 times 8, which is 432 inches cubed. So that wraps up this lesson on volume. If you have any questions, log into Zoom in our next office hours, and I will be sure to answer those. But for now, go ahead and answer the questions below, and I will see you again next time.